Hello, thank you very much to the organisers for the opportunity to speak today. I'm Fraser Binns and I'm here to tell you about some joint work in progress with Stancar Day on botany questions in knot-floor homology. So what is knot-floor homology? Well, knot-floor homology is an invariant of oriented links due independently to Laszlo Szabo and Jacob Rasmussen, which takes value in the category of bigraded vector spaces. And we denote it by HFK et al. So having defined such an invariant is a natural question to ask, namely the botany question, which is which links have knot-floor homology of a given type. And so we're able to answer this question in quite a strong form in a couple of special cases. So some of the things we can show are that knot-floor homology detects T28 and T210. There's a couple of things to point out here. First of all, in general, T22N is the link you get by closing the 2 braid as shown in this picture. So we have 2N half twists in this box here. And the other important thing is that for purposes of this theorem, we're viewing this link as being oriented as shown. Okay, so I'll say a few words about how we prove this result in a second, but first of all, I wanted to give some context. So let me do that. So first of all, myself and Gage Martin last year showed that knot-floor homology can detect T22N for all n, where in this case we orient T22N as the boundary of an annulus. So we can see an annulus embedded in this picture here. And we were also able to show that knot-floor homology detects T24 and T26. And here again, this is sort of oriented with the braid orientation. And so my result with day can be viewed as some kind of extension of this latter result. Okay. So how do we prove our results? Well, here's a rough sketch. So the first thing to do is to assume we've got another link L, which has the same knot-floor homology as T28, and then we want to use the following characterization of T28. So T28 is actually the unique link that has 2 components, has linking number 4. It bounds an annulus upon reversing the orientation of one of the components, and either component of L is an unknot. Okay, so these first 2 conditions here, you can read off from the knot-floor homology without too much difficulty. And so it is showing these latter 2 conditions that requires the most work. So how do we do that? Well, basically what we do is we consider the chain the chain complex of the link floor homology. So link floor homology is a sort of stronger invariant than the knot-floor homology, which comes with extra Alexander gradings. And well, what we're doing here is we're considering the underlying chain complex of the link floor homology. And since the knot-floor homology of L is something called delta thin, meaning it's supported in a particular set of gradings, we can deduce that the link floor homology chain complex is in fact E2 collapsed, which basically just means that it's sort of built out of some particularly simple building blocks. And once you've deduced that, you can sort of understand the components of the link, as well as deduce that L bounds an annulus. Okay, so that's more or less how the proof goes. So I wanted to finish by mentioning a related result we can show. So we can also show that Kavanov homology detects T28 and T10. And how we do this is, well, we basically use similar techniques to the knot-floor case, except we have to sort of combine this with a spectral sequence due to Dowlin from Kavanov homology to knot-floor homology, as well as Bats and Seeds link splitting spectral sequence in Kavanov homology, and finally Lee's spectral sequence. Okay, so that's all I want to talk about today. Thank you very much for your attention.